Hey guys, another chapter 5 section 5 video. So if you're following along in the same textbooks as we are using in class, that's chapter 5 section 5 in our book. And we're working on studying lines now. So the essential question today is, how steep is that line? And we're going to talk about steepness. And we've talked about this in earlier videos too, but we're going to get into it in a little bit more detail. How steep is that line? So for our notes, one of the things you're going to need is a ruler, because we're going to be doing a lot of graphing, and graphing is precise and it's neat and it's organized. So be sure you have a ruler, or even the edge of your binder, the edge of your book. There's a lot of things you can use as a straight edge, just something to keep things neat. And what we're going to do for the notes is we are going to take our graph paper here and basically stretch this up a little bit, draw a big XY axis. So grab something to write with, grab a pencil, grab a ruler. Let's draw a nice long y-axis. There's my y-axis, and a big x-axis, like so. And there's my x-axis. And if it's going to be a good graph, and I want to be proficient at this, I have to have a scale. So I am going to draw little notches on my graph paper to build this scale. Notice I'm using the lines of the graph paper to do this, to make it nice and even and spread out accurately. So I'm going to go through and do that right now. And then I'm going to use numbers to label this. Now to keep this graph easy, I'm just going by ones. So 0 is in the middle. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8 until I run out of room. And then I'm going to go back -1, -2, -3, -4, -5, -6, -7. I can reach -8, just barely. And then I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8, 9. I made it to 10. And I'm going to go down -1, -2, -3, -4, -5, -6, -7, barely -8. Okay. So you can set yours up. You can pause the video if I did that too quickly, because you want to make sure yours is like nice and neat and really well organized. And then what I'm going to do is I'm going to be drawing a few different lines on this graph by plotting and connecting some points. So the first thing I want to do is I want to plot a point that is at the coordinate 3, 7. So I'm going to go to 3, 7, which is up here, and I'm going to plot that point. I'm even going to label it just to kind of help, 3, 7. And then I'm going to plot another point that's out here at -4, and I'm going to go up to 5, -4, 5. And I'll label that too, -4, 5. And let's say that I had a line that was created by just these 2 points. What I could do is grab my ruler and connect those 2 points as accurately and cleanly as I can. So I'm going to do it with a straight edge because I don't want a wobbly line. That looks pretty good. I'm going to draw a nice line that crosses through the points, kind of like that. I'll draw arrows on the line showing that it's going in both directions. And then what I'm going to do is I'm going to measure the steepness of this line. So how steep is this line? And to me, just looking at it, it's not very steep. It almost looks flat. Like if I had to walk up it, it doesn't look like a huge hill to me. But that's just kind of a visual way of looking at it. Let's accurately measure the steepness. So in math, we say that steepness is called the slope of the line. So we want to figure out what is the slope. And the way we figure out slope is we use what we call rise over run. It's a measurement. How much are we going up and over? So we're going to use our 2 points to calculate that rise and run. And the way we're going to do it is by making a growth triangle. So let's see here. I'm going to go over, up. I'm going to grab like a colored pencil here and just kind of shade this triangle. And this is what we call our growth triangle. The growth triangle measures the steepness of this line. How steep is it? And if you'll notice that the rise is the part that goes up and down. So over here, this would be the rise right here. And it looks like it goes 2 squares, 2 units is our rise. So for our rise over run, it's 2 over. And then for our run, it's how much do we go across. So it looks like 1, 2, 3, 4, 5, 6, 7. So the run appears to be 7, equals 7. 7 squares, 7 units. So our run is 7. So if I had to tell you what the steepness of this line is, I would say the steepness is 2/7. That's the slope of this line. Well, how does that compare to a second line that I'm going to put on this graph? My second line is going to have a point that is at 4, 1. So here's 4. I'll label it 4, 1. It's going to have another point that is at 2, -5, which I'll label right here, 2, -5. We're going to compare it to a line that connects those 2 points. So again, I'm going to grab my ruler and I'm going to connect my points and I'm going to try to make a nice straight line, I hope. Let's see here. There we go, kind of like that. Draw some arrows. Now, without measuring the rise and run yet and doing any calculations, just look at the 2 lines. Which one appears to be steeper? If you had to hike up these hills, which hike is going to be more challenging? It's not this one. It's not the flatter one. It looks like this is the steep hike. But we're going to prove that with a number. So we're going to find that rise over run, that slope, and figure out what does it equal. So we're going to make a big triangle that connects these points right here. There's my growth triangle. I'm going to shade that in with my pencil. That way I can see it all nice. There it is. And then I'm going to calculate that steepness. So here's my rise going up and down. So here's the rise. It looks like if I count the units, it goes 1, 2, 3, 4, 5, 6. It's a rise of 6. Okay? And then my run, which I guess I'll have to write it really small down here. Run looks like it's only 1, 2. Looks like 2 units. So we get a 6 and a 2. This is 6 over 2. And fractions mean to divide. I couldn't divide 2/7. I could, but it's a decimal. But 6 divided by 2, I can. It's 3. So the steepness of this line is 3. And the steepness of this line is 2/7. Now think about 2/7 as a decimal. If you really want to know, here's 2 divided by 7. 2 divided by 7 is 0.2857, blah, 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 blah. Basically about 0.2, well, almost 0.3. But that tells you something, that the steepness of this line is like 0.28, and the steepness of this line is 3. Much, much bigger. That is a greater steepness. That value is greater than this one. So by comparing the slopes, you know which one has a steeper line. You can think of it that way. So let's make a new graph. Let's start this over here. We'll make another graph, probably about the same size. So I'm going to grab a ruler and a pencil, and I'm going to draw my y-axis again. Here we go. And I'm going to draw another x-axis. Again, just pause the video if I go fast on these. That way you have time to make yours nice. You want it nice and neat. I'm going to scale it on the graph paper. I'm going to use the graph paper to draw my scale. Here we go. Just do that. But I'm going to do the scale differently than I did in the last problem. So that will be kind of interesting. I'll show you here in a minute. Okay, so I'm going to change up my scale today. For this one, what I'm going to do is I'm still going to count by ones on the bottom. I'm going to go 1, 2, 3, 4, 5, 6, 7, until I run out of room. I'm going to go -1, -2, -3, -4, -5, -6, -7. But then for the y-axis, I'm going to spread it out. I'm counting by 5s. 5, 10, 15, 20, 25, 30, 35, 40, 45. I think I can get to 50 and stop. Then I'm going to do the same thing going down. I'm going to count by -5, -10, -15, -20, -25, -30, -35. I'm running out of room. This is going to change it up when I go to measure my steepness of my line. So again, I'm going to plot some points, and like I said, pause the video if I go too fast on my graphing. But my points are now going to be at higher values. So like my first point I'm going to do, I'm going to go out to -5 here. Actually, let's go to -6. I'm going to go to -6, and I'm going to go up to 40. So I'm plotting a point at -6, 40. This is why I didn't want to count 1, 2, 3, 4, 5, because if I had to count all the way up to 40, I would have had this like huge y-axis. Sorry if that's really loud when I hit probably is really loud on your device when I hit my microphone. Okay, so we're going to put another point on the graph. The other one's going to be at 2, and we're going to say 20 right here, 2, 20. And we are going to connect those 2 points with our line. So, grabbing our ruler, grabbing our pencil, we are going to connect our points nice and neat with a nice straight line. Looks like this. There we go. We'll draw our arrows. And again, we're looking at what is the steepness of our line. So we're studying that steepness. So we're going to find that rise and that run. So over here, I'm going to write rise over run. In fact, in front of it, I'm going to write slope equals. The slope equals the rise over the run. Now let's calculate our rise and run. Let's make a growth triangle. So big triangle going down from this point and over to this point. Same thing I did in the last problem. I'm going to shade it in with my pencil just so we can see that big growth triangle. I think that's kind of nice to do. All right. There's a growth triangle. And now let's calculate how steep is this line. And here's what I noticed. If I was on this line, it's more like a slide. I see it going in the downwards direction. So when I go to find my rise, I'm looking at it thinking, oh, it's actually kind of dropping down, not going up. It's going 1, 2, 3, 4 units down. But what I want to write is -4 because it's dropping. And then I'm realizing this is a really big mistake. This is a common mistake. The rise is not -4 because every time I drop down a unit over here, how much is that on the y-axis? That's not 4 units down. Remember we counted by 5s? So every time I count down 1, 2, 3, 4, it's really 5, 10, 15, 20. So no, it's not a -4 rise, it's a -20 rise. We are dropping down 20 units. Then I'm going to count over. Let's see, my run. 1, 2, 3, 4, 5, 6, 7, 8. It equals 8. But I'm not going to count 5, 10, 15, 20 because if I go down, the units on the x-axis were counted in ones. So here's what we get. Our rise and run is -20, down 20 over 8. And I know 20 doesn't divide by 8, but I could simplify. I could divide this by 4, I think, to make this a little nicer. Let's try that. That would be 20 divided by 4 would be a -5, and 8 divided by 4 would be 2. So our slope, our rise and run, rise over run, is equal to -5/2. We have a -5/2 slope. Watch what this means. -5/2, I'm going to zoom in on this line. Hopefully you kind of follow me on this. If I drop down 5, here's a drop of 5 right here. It's 1 unit. Down 5 over 2. Look, it hits the line. Down 5 over 2. Down 5 over 2. Do you see how that little simplified rise over run fits right inside the big growth triangle? Down 5 over 2. So this slope that we simplified is still the same slope it's the same as 20 over 8. It's just a smaller version, a smaller growth triangle. Kind of cool to see how that works, right? But you gotta pay attention to the scale. Oh, it's so important to pay attention to what's going on here. Okay, so one more line we're gonna put on the graph and then we'll be all set today. We're gonna plot a point that is at -4 and -15 right here. -4, -15. We're going to plot one more point that is at 2, -10. 2, -10. And we're going to connect those points and measure the steepness of that line. So we're going to grab our ruler, line up our points. As I'm drawing my line, I'm thinking about this and deciding is it positive or negative slope, and it's going up. So I'm thinking positive slope. So I'm going to connect the points, draw a nice line, put some arrows on here, and we're going to find our rise and run. And I have a lot of space down here to do that, so I'm going to write slope equals rise over run. There's my rise over run. All right, slope equals rise over run. So I'm going to make a growth triangle that connects these points. Look, it's going to be over, kind of an interesting triangle, and up. So I'll shade this in. let's shade this in so we can see it, and we'll calculate that rise and run. So the rise looks like it's 1 unit. It's really small. So here's the rise. But what does that 1 unit actually mean over here? That's a jump of 5. So it looks like we have a rise of 5. So I'm going to write equals 5. And then if we look at our run, it looks like it goes 1, 2, 3, 4, 5, 6. Looks like we have a run of 6. So I'm going to say 6. So the slope of this line is 5 sixes, and I can't simplify that anymore. I can't think of how to make that smaller. So we're just going to leave it as a positive 5 sixes. So I hope what you'll take away from watching this video lesson is 2 things. One, I hope you really pay attention to your scale numbers because it affects how you calculate rise and run. And 2, I hope you can see that when you simplify your slope, all you're doing is taking maybe a big growth triangle and finding the small ones that fit inside. It's still the same slope, just smaller numbers, smaller growth triangle is all it is. So, and I guess maybe the third takeaway is slope is really a measure of how steep the line is. What is its steepness? So yeah, 3 takeaways. That's a lot of good stuff. Maybe for some of you guys that do a really good job of like writing a summary in your notes, especially avid students, your 3 takeaways might be a great thing to write down as your summary. Thanks for watching, you guys. Hope you're having a great day at school. I will see you in class. Bye.